So in this video, we're going to be solving the equation 3x cubed plus 5x equals 60 to one decimal place. Now, this is a cubic equation. There is a cubic formula, but if you've watched the previous video, as I said, I have never used the cubic formula in my life. And you can look it up. It's really nasty to look at. And I don't think I ever will try and use it. So we're not going to be using a cubic formula or anything. Okay, we're going to use a numerical method. And essentially, we're going to home in on the result. Now, what we're going to do is we're going to start off by subtracting 60 from both sides. Like so. Okay, so if we subtract 60 from both sides, and then to make it easier for myself to write all my notation down, I'm going to let f of x be the 3x cubed plus 5x take away 60. So I'm going to let f of x be that left-hand side. The reason why I'm going to do that is that it allows me to just write down f of a number equals. Okay, rather than having to write out 3 lots of the number cubed plus 5 lots of the number take away 60. Okay, I prefer not to do that. So, let's have a starting value, shall we? So, if you were just solving this from scratch, which I am, okay, with no other kind of method. I've got a calculator, and calculators do have a cubic solver on them. So we will be able to solve that by plugging it into a calculator, but I'm going to assume I don't have that functionality, okay? So let's say we just start with f of 1. So we're going to substitute 1 in. So I'm going to use, in my calculator, there's a table function. So this allows it to substitute these values in quickly. And I suggest you check with your calculator if it has a table function on it, because it's quite useful for this. Okay, so f of 1 is minus 52, which is less than 0. Okay, so we're looking at whether it's equal to 0. If it was equal to 0, then I have found a solution. 1 would be a solution if it was equal to 0. Okay, so let's try f of 2 and see if we're going in the right direction. So f of 2 is minus 26. Now that's getting closer to 0, so this is looking promising. If we try f of 3, then that is 36. And that is greater than 0. So what that's telling me is that there is going to be a solution between 2 and 3, because 1 is less than 0 and 1 is greater than 0. Okay? So essentially I've done what's referred to as an integer search. So I've searched through the integers and found that there is a 1 is positive, 1 is negative. There is a change of sign. And we look at this as the change of sign method when we go on to do it in A-level maths. Okay? But we found a change of sign. So it's between 2 and 3. So what should we try next? Well, should we try 2.5? Makes sense to maybe try somewhere in the middle. So f of 2.5 is minus 0.625. That's still less than 0, okay? So that's telling me now that our solution must be between 2.5 and 3, because between 2 and 2.5, less than 0, there's no change of sign. But between 2.5 and 3, there is a change of sign. So that must mean the answer is between 2.5 and 3. So let's try 2.6. I mean, that seemed pretty close. So let's try 2.6 and see what we get. So 2.6, and we get 5.728. So that's clearly positive, so that's greater than 0. So there's definitely a solution between 2.5 and 2.6, okay? So Now that we've done that to 1 decimal place there, in order to find the solution to 1 decimal place, I need to check which of these it is closer to. I mean, it looks like it's going to be 2.5, doesn't it? Okay. So the way to check it is in a similar way to how I went from these 2 and 3 to 2.5. I'm going to look at the midpoint between 2.5 and 2.6. So I'm going to look at f of 2.55. So halfway between them. So if I substitute in 2.55, I get 2.494125, which is positive. So I know that the root is between 2.5 and 2.55 because that is where I've got a change of sign. It's gone from less than 0 to greater than 0. So I know that x is somewhere between 2.5 and 2.55. Okay, so to 1 decimal place, x must be equal to 2.5. Now, the reason why it must be equal to 2.5 and not 2.6, say, is because, remember, I'm saying that x is between 2.5 and 2.55. So it could be 2.501, could be 2.51, could be 2.52. It could be 2.5499999999. But in all of those cases, because it's got to be less than 2.55, they'll all round down to 2.5 to 1 decimal place. So that is the solution to that cubic equation to 1 decimal place.